If you follow my work on YouTube, you might remember a recent video about building a chat app with React and Firebase. The funny thing about this project is that I basically invited users to come spam the app because I was confident enough that my Firebase rules would protect me. There were a couple of minor flaws in the initial implementation, but what I want to show you now is the actual Firestore security rules that are implemented to this day. And you'll be happy to know that even with millions upon millions of requests to the database and people trying to break it, the live demo is still up to this day, and it just barely exceeded the free tier, costing me maybe $5 to run in total. To understand this example, let's first jump into the database and look at how the data is modeled. We have a users collection where each user ID corresponds to a Firebase auth ID, so again, a one-to-one relationship. From there, we have a messages collection where a user can have many messages. A message document has 4 fields: a created at timestamp, a photo URL, the text of the message itself, and then the user ID, which creates the relationship with the actual user. When I launched the app, here are some things that people tried to do. They tried to create messages with extremely long text, so we needed to validate the length of the actual text property to be less than 255 characters. That's an example of data validation, which you can perform both in your front-end code and on the back end with Firestore rules. People also tried to use a username that did not belong to them. There's nothing really stopping someone from sending a request to the database with a different user ID, so we need to validate that they're the same when that request comes in. Another common hack was to use a created at timestamp in the future. Because the messages are all ordered by their timestamp, it means that messages in the future will stick to the top, even as new messages are coming in. As I mentioned earlier, you should always make sure to have a rule that validates this timestamp if you're ordering data by a timestamp. And then the last thing I'll mention is that many users posted horrible, profane things into the chat, and the only way to control that was to ban those users. The way we ban users in this case is by creating a document with their user ID as the document ID in the banned collection. In this implementation, the banned document is actually just a document without any data on it whatsoever. You could save data here if you want to, but at a bare minimum, you just need a document to exist in this collection where the document ID matches the user ID that you want to ban. Now let's go ahead and jump into our code to see how we implement these security rules. The first thing you'll notice here at the top is that we're locking down all of the documents in the database. You don't have to explicitly do this by default, but I generally like to have this line here just to show that the entire database is locked down. From there, we'll match the messages collection and we'll allow reads if the request auth user ID does not equal null, or in other words, if the user is logged in. The bulk of our logic will be applied to writes. We don't want users to have the ability to update or delete messages, so we'll scope this to the create method only. And I'm going to immediately extract this logic into a function called canCreateMessage, mostly because as a developer, I want the ergonomics and readability of variables. Inside the function, we'll name a variable for each condition that we want to check. The first one, is signed in, should already look familiar to you. From there, we want to make sure the message being created has the same user ID as the auth user ID. So we check those two values together, the request auth user ID and the request resource data user ID. From there, we want to perform a little data validation. We want to make sure that the text on the incoming data is less than 255 characters. We can do that by grabbing the request resource data text value, which is a string, and a string has a size method that we can call, which will give us the length of characters in that string. Then we can use the less than operator and 255, which is the length that it should be less than. From there, we'll declare a variable isNow, which makes sure the timestamp is valid. The request time should equal the request resource data created at timestamp. Then the final thing we want to check is whether or not a user is banned. In this case, what we actually want to check is whether or not a document does not exist in the banned collection for this user. We can do that by using the exist function and making sure that it equals false, which of course would mean that the user is not banned. Then we can add the entire path to that database location, which is the banned collection, and then we'll interpolate the request auth user ID with a $sign in parentheses. And finally, we'll add a return statement, which will check one thing after another. These can be ordered however you want, but just remember to add anything that uses get or exist to the very end so it short circuits before it gets to that actual call that will cause a document read. Even though we're checking 5 different conditions here, we can fit them all into a single return statement, making it much easier to understand what's going on.